Hey everyone, so today we're going to be taking notes on radical expressions. Day one. So first we're just going to start out with a little bit about indices or an index. And the nice part is we already kind of prefaced this with the last section on fractional and rational exponents. So in a general sense, an index, I've spoke about it, is a small little baby number on the outside of the radical. It tells you how many groups of things you're looking for. So when I said the cube root of 8, I'm looking for what 3 things multiply to 8? That was 2. Okay, square root has an index of 2. Notice, if you don't write anything as an index, it just means 2, because basically mathematicians were like, you know what, we use square roots so often, we're not going to always write there's a little baby 2 right here. So if it's blank, just realize that means square root. Okay, so you guys have seen this. Top goes inside, bottom is that index. And I also want to write this for you this way. You can also write the nth root of x all to the nth power. So that is equivalent to having the exponent inside or outside, just as a heads up. Let's practice really quick. And we've done some of these due to our previous lessons. So x to the 1/3, the cube root of x to the first. So I'm not going to write the first. The square root of y. Now, I could write the little 2, or I don't have to, because it's a square root. The cube root of x squared, or the cube root of x squared. Okay, so I just want to let you know those are equivalent. This guy, 5th root of a to the 4th. Okay, and if I had something like 5th root of a to the 6th, I would want to simplify. So we're going to talk about that because we're looking for groups of 5. There are 5 a's available. So we're going to talk about how we are going to simplify some of these pieces. All right, negative on the outside, negative 8th root of x to the 5th. And I know sometimes these are just hard to say out loud because it's just new to say 8th root. That's how we say it though. Notice parentheses, the square root of 5y versus if I have 5 and then y to the 1/2. Okay, so notice the difference between these two. And last but not least, the cube root of 2x plus 4 squared. We cannot distribute that squared because this is a binomial. So that's all we can really do there. So there's your translating. How about going backwards? What if I give you a root? Can you give it back to me as an exponent? So cube root of x, x to the 1/3. The 4th root of x cubed, x to the 3/4. Okay, careful with this one. 4x to the 5th, all to the 1/7. Now the reason this isn't to the 5/7 is notice 4 technically has an exponent of 1. So another way you could write this is 4 to the 1/7 times x to the 5/7. But we cannot say the whole thing is to the 5/7 because 4 is not raised to the 5th power. So just be careful there. 4x minus 1 to the 2/3, again, inside to outside. Okay, and I threw this one on here because it's such a common mistake. The square root of p squared plus q squared. All I can do here is p squared plus q squared to the 1/2. You cannot break up this radical because there's a plus sign. It's a binomial. You also similarly cannot distribute. Okay, so this is all we can do. Again, that's because it's a binomial. It has 2 separate terms that are not multiplied together. They're added, so we cannot distribute a radical or an exponent. All right, quick fun one for you guys, double radicals. If you see this double radical situation, it's actually got a really easy trick, and I'll show you how to get there. So take a look at this one, the 6th root of the 3rd root of x. Okay, now really this means x to the 1/3 to the 1/6. Okay, if I have a power to a power, I multiply x to the 1/18. And if I start in radical form, I want to end in radical form. So x to the 1/18 is the 18th root of x. Now, instead of all that work, look what happened. 6 times 3, 18. 9 times 3, 27th root of 2. And that's it. So if you have a double radical, just multiply those two numbers together. That's the easiest. Multiply the two indices together. Easiest way to fix those up. And just a heads up, which you kind of knew already, if the index is even, such as the 4th root, the radicand must be positive, meaning it must be a positive inside. Okay, if it was something like this, with a negative inside, we would get no solution. If we have an odd root, such as cube root of 27, it can be positive or negative. Cube root of positive 27 is 3, versus cube root of negative 27 is negative 3. So it will just have the same sign as whatever's inside. If it's positive cube, you've got a positive answer. If it's a negative cube root, you've got a negative answer. Okay, so, and again, this goes for 4th roots, square roots, 6th roots, 8th roots, and odd, we've got cube roots, 5th roots, 7th roots, etc. So let's try a couple of these out. Okay, and just be patient with these. Think about how to simplify square roots. This is really similar, but we're just gonna actually jump into doing some of these tougher roots. Of course I know I skipped these. I'm gonna go back really quick. I talked about them, but not really. So scan back here really quick. How about square root of 108? Let's just flash back to algebra and geometry. How do we simplify square root of 108? Okay, my recommendation is try to think of a big perfect square that goes into 108. But if you can't do that, then just think of any two numbers that go into 108. Okay, so I'm thinking of 36 and 3. Okay, when you're taking the square root, if you ever have a perfect square, you can take it to the outside, and we get 6 root 3. Okay, but even if you did something like, I don't know, how about 12 times 9? Okay, pretend you did 12 times 9. I don't know, you thought of something. You also could do this, 12 times 9, you could break 12 down to 4 and 3. You could break 9 down to 3 and 3. You could break 4 into 2 times 2, 3 times 3 times 3. You could break 108 down into these 5 prime factors, and then for a square root, I'm looking for groups of 2. So a group of 2 gets to come out, and a group of 3 gets to come out. When you take multiple numbers outside, you just multiply those together. So this would be 2 times 3 times the square root of 3, which is 6 root 3. So notice both of these situations are the same. You get 6 root 3 either way. And let's just try one new one here, guys. How about the cube root of 81? Okay, so cube root of 81, well, what is 81 made of? 81 is 9 times 9. Okay, and that really means 3 times 3 times another 3 times 3. So 81 is made of 4 3s. So if I say groups of 3, that cube root I'm looking for, how many groups of 3 can I take out? Well, I have one group right here. When I take it to the outside, I take the cube root. This is really a 27, right? So 27, cube root of 27 is 3 times the cube root of 3, the leftovers in there. Okay, so we're going to try more of these. Sorry I skipped this earlier. I'll jump back now. So let's skip down now to the simplifying, and then we're going to try, we're going to finish this up. All right, so we've got some simplifying and multiplying, this little section here. The nice part is, honestly, it's pretty much the same for multiplying. Let's try a couple simplifying. I'm going to try 1 or 2 multiplying and then be done with it. So cube root, let's try this again. So cube root of 27, my recommendation, if you don't know anything about 27, just start breaking it down. 27 is 9 times 3. And 9 times 3 is 3 times 3 times another 3. And even for the sake of example, let's write out the 5 x's we have. Okay, what does this little baby number represent? That says the only things that are allowed to leave are perfect cubes or groups of 3. So I have one group of 3. I have another group of 3. And those get multiplied. So 3 times x, that represents the 2 groups that I took out, times the cube root, what do I have left? X squared. I have 2 x's left. So here's my final answer. All right, Let's try a couple more here. So how about the fourth root of 16x to the ninth? Okay, so 16, maybe you already know it's a perfect fourth root, but maybe not. So you start breaking it down. You're like, 4 times 4, and again, I've got 9 x's. You definitely don't have to write them. I am just doing it for the sake of example. I just want to show you one more. Fourth root of 2 times 2 times another 2 times 2, and then I've got 9 x's. 3, 4, 5, 6, 7, 8, 9. You'll see why I don't do this anymore, but I want to show you, kind of visually what's happening here. So I broke it down into all the pieces. I'm looking for groups of 4. That's what this little index is telling me. So I have one group of 4. I have another group of 4. And I have another group of 4. But again, what could I have done? Just look at 9 and say, okay, how many times does 4 go into 9? 2. And then I also have 1 left over. So this is going to give me a 2 on the outside. I've got x squared, again, because I had 2 groups of x's come out, times the fourth root of just x left over. Let's try to shrink this down here. Okay, I'll save this one for tomorrow. We're gonna try out this guy, and then we'll move on to some multiplying. So let's look at a fifth root, okay? If there's already a 2 on the outside, by the way, everything else you move out, just multiply it out there. So take a look at the fifth root of a negative. Here's my hint on that. If you have an odd root of a negative, that's okay, right? We can take odd roots of negatives. Just move the negative to the outside, honestly. Because it's like you're taking the fifth root of -1, which is just -1. So my recommendation, move that negative to the outside. Now let's look for groups of 5. If you don't know anything about 64, I'll give you a hint here. 64 is 2 to the 6th power. Now, if you didn't know that, just start breaking it down. You've got 32 times 2, 16 times 2 times 2, right? If we break it down, 64 is made of 6 twos. If you weren't sure, try it out. 8 times 8, break those down, 6 twos total. Okay, and notice for a fifth root, we're looking for groups of 5. Since I have 6 twos, I'm going to take 5 of them. For x's, I'm going to take one group, and I'm just going to have one left. So I'm going to have -2, it was already there, times a new 2, I just brought it out, times one group of x's, times one group of y's. And what's left over here, guys? What's left over inside? We've got fifth root of, I see a 2 left over and an x left over. So final answer here, -4 xy times the fifth root of 2x. Okay, again, we're going to save this guy. So those two will go over in class. I'm going to try one multiplying one with you. The nice thing about multiplying is that pretty much it's the same thing we were just doing, but we're just multiplying 2 radicals together. So if we have the same index, we can combine the 2 radicals. So for example, let's take a look at, how about this guy? So the fourth root of 12x cubed times 54x to the 9th y to the 7th. So here's what's going on. Okay, if I have 2 fourth roots, I can just combine them into one huge fourth root. My recommendation is don't actually multiply 12 and 54, just write them like this. Because honestly, multiplying 12 times 54, then you just have to break it up again. So 12 times 54, x, how many x's do I have? 9 plus 3, so I've got 12. And then I've got y to the 7th. Okay, so let's try breaking this up here. Fourth root of, okay, 12 is 4 times 3. 54, I guess I'll do, how about 9 times 6? X to the 12th, y to the 7th. And again, just keep breaking those numbers down. It's up to you how you want to do this. I kind of think the easiest way is just to get primes for some of these numbers. 2 times 2 times 3. 9 is 3 times 3. 6 is 3 times 2. X to the 12th, y to the 7th. And I don't want to overwhelm you with these numbers. I encourage you to just figure out whatever numbers come to your head for multiplying and just break them down into those primes if you need to. So I'm just going to organize, no matter what you did, you can pause if you need to. How many 2's? I had 3 2's, 1, 2, 3, and then I had 4 3's. Then I still have x to the 12th, y to the 7th. All right, so by multiplying these two things, my recommendation is multiply them together and then simplify that final radical. We're looking for groups of 4. I've got one group of 3's. X to the 12th, I've actually got 3 groups, so I'm going to have an x cubed out there. And then y to the 7th, I have 1 group, so I'm going to have 3 y's left over. Okay, 3, 1 group of 3's. X cubed, because I actually had 3 groups of x's, because I had 12 x's. And then I've got 1 group of y's. I had 7, which means I have 3 left over. So times the 4th root, I've got 3 2's left, which gives me an 8, and y cubed left. So 3x cubed y times the 4th root of 8 y cubed. All right, that's about it. We're going to go through the rest of these in class, as I mentioned. So again, hopefully you got the main gist of those simplifying. I know those are a little bit tough, but please come in with questions. And yeah, thanks so much for watching. Have a great rest of your day.